Of every study that I've ever done, and there are many, many, many studies, hundreds and hundreds, probably more like well over 1,000. And in each case, it is always the same basic breakdown. Hard hit balls happen in four basic ways. This is a quick study of the Mets pitchers versus Kansas City in this year's World Series. At-risk pitch number one is the most common hard hit ball. Typically, that one makes up about 45 to 50% of all the hard hit balls. In the case of the Mets, it was about 60%. And this one is any pitch thrown within 6 EV miles an hour of the last pitch. So sameness. Hitters get prepared for a pitch. The other one that's close in speed, they have a strong tendency to be able to adjust to that easier. And so any pitch, and the most common one is a fastball, let's say 95 thrown middle is really 95 EV, followed by a 92 EV mile an hour fastball. So 95 located middle away. That's the most common hard hit ball, is fastball, slower fastball. Another really common one is a slider that misses and slows the hitter down a little bit, and then it's followed by a faster slider. So in other words, slider off the plate and then a slider strike. That one typically gets hit hard as well. The second category is at risk number two, a little bit controversial because some people, when they look at a sabermetrics, for example, they're going to look at not as much hard hit ball rate, but more towards slugging percentage, batting average, and anytime those two things are used, they're very inexact. And you can hit a ball off your handle and have it be a game-winning double, scoring 3 runs, and you're nowhere near being close to 100% on time. And the study of effective velocity is all about controlling exit velocity or controlling the hard hit ball. And so the slugging percentage and the batting average are two numbers that can correlate, but they don't necessarily have to. They're very random. They can be. My studies are based entirely on hard hit balls and nothing but, because when you control hard hit balls, you control the hitter, and it really is that simple. You can lose because you give up 3 non-hard hit balls or 1 non-hard hit ball, and it ends up being a game-winning fisted single. It's just that you can't control that, and so therefore it doesn't make a whole lot of sense to measure it. From the onset of the game, pitchers have located fastballs on the outside part of the plate. And so hitters have been drawn to the outside part of the plate on fastballs, and that is typically about 3 miles an hour slower or more. And so when a hitter sees a pitcher throwing 95 miles an hour, what really comes to mind is about 92, because the pitch is going to lose between 2.5 to 3 miles an hour when it's located middle away. And so the hitter thinks 95, he sees the scouting report at 95, but it's really a 92 mile an hour fastball that he's used to squaring up. So that hitter has what's called an attention zone. And the attention zone is the speed range that, from our example of 95, any pitcher that throws 95, their attention zone is going to be 92 down to 87. Every pitch thrown within that speed range. So that could be a fastball at 95 middle away. It could be a slider at 87 that's thrown on the diagonal, so it's really is 87. It can be a number of pitches, but anything within that speed range is very at risk. And so in most cases, this is going to be about 20% of all the hard hit balls. In the case of the Mets pitchers versus Kansas City, it was also about 20%. The first category was 60%. This category is 20%. So 80% of all of the hard hit balls given up in the World Series by Mets pitchers, 80% were of those in those at-risk pitches. The not at-risk pitches that result in hard hit balls, I'm going to refer to these as non-tunnel. They're pitches that are thrown that are easy to recognize. When you see a fastball that is thrown and it's got a slight downhill and it's located down and away, and then the following pitch is a curveball, it's going to have a hump or it's going to pop up over the the fastball. So it's very easily and very early recognized. And that type, even though there might be a large speed difference between these two pitches, this one is easy. This scenario is easier to hit. And so it's not technically at risk, but it's a very common hard hit ball. This is about 20% of all hard hit balls in general. In the case of this World Series, it's 11% of those given up by the Mets pitchers were in this category of non-tunnel hard hit balls. The last one is always the same. It's going to vary a little bit from 5 to 15%, but it's always within that range. In this case, it was only 9% of all the hard hit balls given up by Mets pitchers were in that earned category. So this is the category of EV efficiency. That means that the pitches had tunnels, so they were hard to identify. The pitches had 6 EV miles an hour differentials between them. When that scenario is followed, hard hit ball rates go down dramatically. And so that's the place that guys that are black belts in EV are trying to live in that area. It's not very it's not impossible to do. It seems like it is, but when a pitcher locates fastballs in the right areas and has his pitch design done correctly, and then just locates fairly consistently, he can avoid at-risk pitches a great deal. There's always going to be some accidents. There's always going to be mislocations. But when pitchers live in this area, in the not-at-risk type pitches, hard hit balls go down dramatically. Let's take a look at some of the pitch by pitches. Basically, what you'll see by and large is fastball. This one is at 91 if we look at the speeds down below. This one is at 91 up and in, so it's about 97 EV, followed by 92 on the diagonal. Fastball, slower fastball. That one's super common. Slider at 86, followed by a slider just less than 86. They're both 86 in what the radar gun says they are, but from an EV perspective, this second one is slightly slower, but they're still within 6 EV miles an hour of each other. This one is a fastball located off the plate at 92, but it's really in an area that's going to be losing quite a bit of effective velocity. This one is in that category where it's about 87 EV, and then it's followed by a slider that's at 84 on the diagonal, so it really is about 84. And this one's kind of double at risk because the first pitch is going to have a look something like this, and this pitch is going to have a tunnel that's it's nowhere near the same tunnel as the fastball. So this one is ultra obvious out of the hand, and it is within 6 EV miles an hour of the last pitch, so it's double at risk. All we're trying to do is point out pitches that are the sameness. If we think about deception, what's the opposite of deception is obviousness. And one of the first things that's obvious is when you throw pitches that have the same speed to the mind's eye, they're more likely to get hit hard. This one is 89, located in an area where it's losing speed. This one is at 88, losing roughly the same amount of speed because they're about the same distance off that diagonal. So when you start to look at pitches over and over, and especially hard hit balls, you're going to find the same thing that I find. And that is when pitchers throw fastball, slower fastball, they're much more at risk of being hit hard. When the fastball is located here, followed by a slider coming out of the same tunnel, and they have a 6 mile an hour differential, they're far less likely to be hit hard. And you will see this over and over. Fastball, slower fastball. Even though the speed of this sequence is 98 and 97, the 98 is on the line, so it really is 98. The 97 is losing a couple of miles an hour, probably about 95 EV, 94 EV, I should say. So 98, 94. When you see a fastball and then a slower fastball, you're at risk. You're asking for trouble. This one is a fastball followed by another fastball. The speeds are within one of each other. But this one is a case where the fastball is a little bit faster than the last one, but it's still within that range because it's on the diagonal instead of in a place where it's gaining speed. It's still at risk within 6 of the last one. Fastball at 92 is the first one, pitch number 3 in this sequence. And then pitch number 4 is actually a little higher, so it's got a little more EV value. It's added to it. But it's in a place where it's losing speed and it's slower out of the hand. And so that's a pitch that's hit hard very often. When we continue down this, you just keep seeing the same thing over and over again. Fastball, slower fastball. This is fastball within 6 EV of the last one. Even though they're in the same basic place, it's still fastball, same fastball. Sameness is what the key to this type, this at-risk number 1. Fastball, slower fastball. You see it over and over and over and over. Same thing with the lefties. We'll start to see some at-risk number 2s, and this one is thrown where these two can't be in the same basic tunnel because they're 2 different speeds going to the same place, so they can't look alike. And this pitch is at 94, but it's losing velocity, effective velocity, and is going to be in that 90 speed range, 91, somewhere in that vicinity. We haven't talked about the hitters. This hitter in particular has about a 750 hard hit ball rate in that general area. I think it's about 450 in that area. So when you are facing a hitter in general, effective velocity just looks at all hitters as the same basic reactionary skill level. But many of them are so tuned into one particular area. So the double that results off of Harvey in this case was super at risk, and it has nothing to do with Harvey getting tired. He located that fastball where he wanted to, but it was exactly in the wrong area for the particular hitter that he was facing. But you will see the same speed when you add in the location. This is 83, that's just off the line, so it's probably about 81. And then it's followed by an 88 mile an hour changeup, but it's losing more speed. So the 88 is going to be closer to 84. So 81, 84. That's just basically what you see day in and day out. Our fastballs, this one I put a little question mark on because when a pitcher throws 96 like Harvey does, 98 up to 98, but he throws a fastball at 94, it's less than the speed. When this hitter goes to the plate, Zobrist is thinking 98. His brain is immediately drawn to 94, 95. So when you throw 94, 95, but you throw it on that diagonal or slightly less than that diagonal, you're throwing it exactly in the speed range that the hitter is the most tuned to. When we start to get down towards the end, we start to see at-risk number 2, and then the non-at-risk pitches. When it's located down and away, no matter the speed, it's losing speed, and it's in that area where the hitter is the most prepared to hit it. So you will see countless hard hit balls on fastballs down and away, fastballs away. And the reason for that is because that's where they're drawn to. At-risk number 2 is that. It's the attention zone. And every hitter has an attention zone. regardless of how great they are. These are examples of non-tunnel hard hit balls. They're not at risk, and so I didn't count these as pitches that are at risk, but they are pitches that are not advisable. Fastball down and away, followed by an off-speed pitch at 86, curveball in this case. This is going to have this type of hump to it, so he will recognize that out of the gate. And so the fastball at 92 is really 90 EV or 89 EV, and this 86 is really about 84. So the pitches that are close in EV and they're easy to recognize are typically in a lot more trouble. So this was a line out, even though it was not it was a hard hit ball, but it was not a hit. But when you look at it from an EV perspective, we have to count these. We have to look at these because these are the ones where the hitter is on the pitcher. And it's always going to be the same thing. The pitches that are off-speed pitches at the top part of the zone cannot have the same deceptive tunnel as a fastball at the bottom part of the strike zone. So that's what you're going to see very often. Even this fastball at the top of the zone, any speed that's slower than that has to have a little hump to it, so hitters are going to recognize it. And then finally we get into the ones that are earned. If it's on a first pitch, we have to assume that the fastball here is going to hide this slider. So this one I put always into the earned category because we're assuming he's got to be able to start somewhere, and the hitter always starts somewhere. And the off-speed slider is going to have the same basic tunnel as this fastball that would be on the inside part of the plate. So that one gets thrown into that category. Fastball, a slider, curveball on the outside part of the plate, and then a fastball in the plus part of the strike zone. That one was a hard hit ball that he gave up. But again, when you look at it, technically this is not at risk. But when you realize that Matt Harvey throws 98 and this one is only at 92, technically it's the same as him throwing 98 on the outside part of the plate. So this would probably go into the category of attention zone. I put this one in just as an example in the non at risk because technically it's got that, but it's not technically not it's not going to be safe unless it's 98 in there. And it's not that it's safe. It's that when you follow the idea of hiding your fastball off of a curveball and using the same tunnel with a changeup, those three pitches are all going to be really difficult for the hitter to recognize. And so day in and day out, when pitches are located, fastballs are located where they're gaining speed, you've put a bigger spread between the pitches, the off-speed pitches. And so those are the ones that are not at risk, and those are very rare indeed. It just doesn't get hit all that often. So this fastball and this curveball would basically have the same type of tunnel. So when pitchers do this day in and day out, they have a ton of success when it comes to hard hit balls. When they live on the outside part of the plate where the fastball is losing speed, you're not maxing out the effectiveness. Anything on this side is gaining, anything on this side is losing, and the fastball that's losing is in the area that this guy, we're doing him a favor. And it really does come down to just that. This would be an off-speed pitch, a changeup that didn't quite make it to the area where it's supposed to be, but still it's put into that category of if the fastball were thrown, we have to assume that would have been a great tunnel. So every changeup that Clippard is going to throw that's located in this area at this basic velocity, and again, 80 is a little slow, so it's going to have a little bit of a hump to it. So I tried to be conservative. Technically, this would be the basic area that 80 would have to be in order to have the best tunnel. So fastball in this basic area, actually a little bit larger than that, in this basic area is going to have the best tunnels right in here. and that changeup would look almost identical to that. So even though this is definitely going to have a little bit of a hump because it's located towards the top part of the strike zone, I still put it in that category of earned hard hit balls. But with all that said, and being as conservative as I can, still only 9% of the hard hit balls given up by Mets pitchers were earned.